Okay everyone, so this is a video on expanding brackets within area problems. Now before we start doing those problems, I just wanted to go over the different ways to find the area of different shapes. So the first two shapes are rectangles and parallelograms. They have the same formula to find the area, and that is the base times by the perpendicular height. Now it's really important you use the perpendicular height. In a rectangle, the base and the height are already perpendicular, they are already at a right angle. Whereas in a parallelogram, the base, which I've highlighted here, is perpendicular to the height, which is here. So the slanted edge of a parallelogram is not the height of the parallelogram. So just make sure that you're using the perpendicular height. The next shape is triangles. So the formula to find the area of a triangle is base multiplied by the perpendicular height divided by 2, or today I'll probably use this one quite a lot, which is a half times the base times the height. And again, we must be using the perpendicular height. So for this triangle, I've labelled the base here. Now the height is not either of these two edges of the triangle. The height actually goes through the triangle like that. They must be perpendicular at a 90-degree angle to each other. So base times height divided by 2, or a half times base times height to find the area of a triangle. And lastly, we have a trapezium. So trapezium, we can use the formula a plus b divided by 2 multiplied by the height. And in fact, I'm going to change this to HP as well, because we still have to have the perpendicular height. But today, I'm going to be using this formula more, just because it works a little bit easier with my algebra. So a half multiplied by a plus b multiplied by the perpendicular height. Now, A and B are the side lengths that are parallel to each other. So in this trapezium, A and B are these two side lengths. And then the height has to be perpendicular to both of those. So this is my perpendicular height. It is not one of these diagonal slanted edges. The height is perpendicular to A and B. So a plus b all divided by 2 divided by 2 multiplied by the height, the perpendicular height, or a half multiplied by a plus b multiplied by the height. So we'll be using these three formulae, or these equations, to find areas of shapes. And all of the shapes today that we look at will have lengths that are, or at least one length that is algebraic. Okay, and we'll be using the skills we've learned in expanding brackets to help us. So in all of these examples, we're going to be finding simplified, we're going to find simplified expressions for the area of these shapes. So these expressions are going to be simplified. We need to make sure that we collect like terms at the end of our work. So the first example we'll do is this rectangle here. So we can see this rectangle has lengths 2 plus 3t centimetres and t plus 12 centimetres. And we know to find the area of a rectangle, we do the base multiplied by the perpendicular height. So that's from up here. So we need to do 2 plus 3t, which is the base, multiplied by t plus 12. Okay, so we are multiplying two brackets together. Now we have been using grid method to do this, so I'm just going to do my grid method. I'm going to do it in a different colour. So my grid method will be I'm multiplying 2 and positive 3t by t plus 12. So this is my grid method. And filling in my grid, I've got t multiplied by 2, which is 2t. T multiplied by positive 3t, which is positive 3t squared. 2 multiplied by plus 12, or positive 12, is positive 24. And positive 12 multiplied by positive 3t is positive 36t. Now I know that I have to add all of these together, so I'm going to have 2t plus 3t squared plus 24 plus 36t. And I need to collect my like terms, and I can see here that I have like terms with positive 2t and positive 36t. So my final answer to this question, these two brackets multiplied together, is going to be, I'm going to put my square term first, so 3t squared, then my t term, so 2t plus 36t plus 38t, and then plus 24. And all of this, well, this length was in centimetres, this length was in centimetres, so my units for the area will be centimetres squared. So my final answer for the area of this rectangle is 3t squared plus 38t plus 24 centimetres squared. The next example will be a triangle. So I can see this triangle here. I know that to find the area of a triangle, I need to do, I can either do base times the perpendicular height divided by 2, but actually I'm going to use a half times the base times the height. So a half multiplied by the base multiplied by the height. I put brackets in it before, but it's fine to take the brackets out as well. So I just need to make sure I know what the base and the height are. So looking at my diagram, I can see that this length 8 plus 3x and this length 2x, they are perpendicular to each other. So they are going to be my base and my height. These edges of the triangle here, or these side lengths, are not the base or the height. So my base is the 8 plus 3x and my height is the 2x. And I need to do a half times the base times the height. So I need to do a half multiplied. Now my base is 8 plus 3x, and I'm going to put that whole thing in brackets. And then I'm multiplying the height, which is 2x. Okay. Now in these questions, I think it's probably best to leave the half till the end. So multiply by 1/2 at the end of the question and sort out your algebraic lengths first. So first I'm going to do 8 plus 3x multiplied by 2x. And I'm going to use a grid method for this, but it's only going to be a small grid method because we're just expanding one bracket here. So it's not an expanding double brackets problem, it's expanding a single brackets problem. So my grid method will look like this. So I have 8 and then plus 3x, and I'm multiplying that by 2x. So this is a single bracket problem. So multiplying this through, 8 times 2x is 16x, and 2x times by positive 3x is positive 6x squared. So adding these two things up, I get 16x plus 6x squared. So that is 2x multiplied by 8 plus 3x. But remember, I need to multiply this whole thing by a half. So I still need to do a half times by this thing, 16x plus 6x squared. And I've put that in brackets because I need to multiply the half by the whole thing. So I'm going to have to go up here in my work. This is also like expanding a single bracket, and if you want to, you can do a grid method for this. I might do a little one just to show you. So we've got 16x plus 6x squared, so to make sure it fits, and I'm multiplying that by a half. So I'm expanding this single bracket here. Now a half times 16x will be 8x, and a half times 6x squared, oh I forgot my positive there, is positive 3x squared. So this now is my final answer to the question, because I've expanded a half multiplied by this bracket. So my final answer for the area is, and I'm going to put my square term first because we learnt that's the convention that we follow, is 3x squared plus 8x. That one is a little bit squished, that example, but hopefully it's visible. Oh, and I forgot my units. So because I've been working in centimetres, my units would be centimetres squared. So I'll just add that on to my final answer. So we've done a rectangle and we've done a triangle, so I'm now going to do a trapezium. So over here I've got a trapezium, and I want to find a simplified expression for the area of this trapezium. And looking back at my equations that I can use, I could use a plus b over 2 times by the height, but instead I'm going to use the one below that. I'm going to use a half times by a plus b times by the perpendicular height. So this equation here. So I've just rewritten that next to my work. So I need to do a half times by a plus b times by the height. I'm first just going to identify my side lengths. So remember, a and b are parallel to each other, and I can see that these two lengths here are the parallel lengths. If I was to carry these lengths on, they would never meet. So a and b are these two lengths, and the height is the perpendicular height, and I can see that 10 centimetres is perpendicular with a and b. So 10 centimetres is the height. So like I did with the triangle, I'm going to leave this one half until the very end, okay? And I'm first actually going to work out what a plus b is, okay? So I'm going to work out what a plus b is, and I'm going to write it in these brackets. And then my height, we just decided was 10, didn't we? So I'm going to write that in. But my first job is to find out what a plus b is. So I'm going to look over here at this triangle. Now a and b are these two lengths, so I need to add those together. So 4y plus 1 added to 7y take away 2. Now I'm not multiplying these, I'm just adding them. So I can just collect like terms. So I can see 4y and positive 7y can be collected to 11y, and positive 1 and then plus negative 2, so 1 plus negative 2 is actually 1 take away 2, isn't it? So that's going to give me negative 1. So when I add a and b together, I get 11y take away 1, and I'm going to write that over here in my expression for my area. So it's 11y subtract 1. And now I can multiply by my height, and then I'll leave the 1/2 until the very end. So I'm going to multiply by my height. Now you should be really good with multiplying single brackets. Now I'm not going to do a grid method for this one. So when I do 10 multiplied by this whole bracket, I'm going to get 110y subtract 10. And then I need to multiply this whole thing by 1/2, and I won't do another grid method for that because we should be very confident with single brackets. I'm going to get 1/2 times 110y is 55y, and 1/2 times negative 10 is negative 5. So All of this is going to be in meters squared because that's the length being given to me, although this one is centimetres, which I'm going to get rid of. And that's my final answer. So the area of this trapezium is, written algebraically, is 55y take away 5 meters squared. Okay? And then this last example is going to put some of this all together. So in this last example, I'm going to find the area of this shaded region, this yellow region here. And I can see that this shaded region is equal to the area of this large triangle, which I'm going to write as AT, take away the area of this little rectangle here. So to find the area of this shaded region, the yellow region, I need to do the area of the large triangle, and then I need to take away the area of that rectangle. So what I'm going to do is somewhere else, so away from my main working out, I'm going to find the area of the triangle and the area of the rectangle. Okay, so I might even draw a little line here to show that this is my kind of neat work, and over here I'm going to be doing some rough working to find the area of the triangle and the rectangle. So first I'll do the triangle. So first I'm going to find the area of the triangle. Now we know that we can use these equations that we've got here. I'm going to use a half times the base times the height. Perpendicular height. So the base and the height are 6h take away 14 and 4h. This diagonal length here, this doesn't contribute when I find the area. It isn't the base or the height. So I need to do a half times by the base, which is 6h take away 14, and that whole thing needs to go in brackets, times by the height, which is 4h. So again, we're multiplying with single brackets again here. So I'm going to leave my 1/2 until the end, and I'm going to multiply these single brackets here. 6h take away 14 multiplied by 4h. I won't do a grid method because we should be very confident with this. So 4h multiplied by 6h will give me 24h squared, and 4h multiplied by negative 14h is going to be negative, so 14 doubled is 28, and then double that is 56. So it will be 56h. And then I'm multiplying single brackets again, because I need to multiply this expression by 1/2. So I'm just going to do that over here. So I'm going to get a half multiplied by 24h squared, which is 12h squared, and a half multiplied by negative 56h, which is negative 28h. Okay, so this is the area of my triangle. And in fact, I might even write that up here now. I'm going to put it in brackets, 12h squared take away 28h. And now for the area of my rectangle. I'm going to call that AR. I'm just going to do the base of the rectangle multiplied by the height of the rectangle. So looking back at my diagram, I can see that the base is 2h plus 1, which I'm going to put in brackets, multiplied by the height, which is h. And this is a single brackets, expanding single brackets question. So I'm not going to do a grid method for this one, but the answer will be 2h squared plus h, because 1 multiplied by h is h. So I'm now going to write the area of my rectangle up in my expression over here. So I'm going back to my neat work. So that's take away 2h squared plus h. Oops. Now we do need to be super careful about this negative here, because overall what I'm doing is 12h squared take away 28h, then I'm taking away 2h squared because of this negative, and I'm taking away h as well. Now I need to collect like terms. So I can see that 12h squared and negative 2h squared are like terms, and they will collect together to give me 10h squared. And then also negative 28h and negative h are like terms, and they will collect together to give me negative 29h. The units for this whole thing would be in centimetres squared. So the area of this shaded region is 10h squared take away 29h centimetres squared. It's definitely a tricky question.